Hello everyone, this is Devik Maheshwari with my project Shinrai. Shinrai is a leverage provider on top of Uniswap pools, which provides leverage using the abundant assets in any Uniswap pool. Shinrai has three major components. First is the leverage hook, second is the margin daughter contract, and third is its ability to identify abundant asset and scarce asset and issue leverage loans to traders on top of Uniswap pools. Before this boring PPT, let me show you how the actual demo works. So I have deployed my Shinrai live on shinrai-atrium.personal.app, but I'm going to be showing you on my local host how this is actually working. If you want, you can test it out live right now. It's going to work. So yeah, we have logged in to the leverage sharing platform of Shinrai. First of all, we are going to be creating pools. Let's create pools first. So the pools are going to be created using Sepolia tokens which are deployed in Sepolia. Let's mint the contracts. And so we have minted two tokens on Sepolia. First, we have named them test token 1 and test token 0. Let's see, control V, and it's, oh, yeah, let's see. Well, test 1, test 0. Now we can choose the leverage we want, 2x, 3x, 5x, or 10x. We can use the borrow cap. We can choose the initial price. Let's do at 10x only. So now we're going to validate tokens if they are perfect, if they are on Sepolia, if they can work in a pool together. Then we're going to generate the pool key, then initialize pool. This is my custom pool manager contract, which I've deployed on top of the Sunisap's pool manager contract. Oh, let's also see in the inspect how things are working. So this is the pool authorization, which we are confirming from our wallet that the one creating the pool is an authorized wallet or not. Let's also look in the console how things are working. Yep. So the pool is created. Uh, Pool initialize function has been called. Pool manager got initialized. And here are the pool parameters. So yep. And so now you can see we have the pool address here, and we have the two tokens which are going to be using to create a new position. Let's add the collateral token. So the collateral token, let's keep it 100. Then the leverage is going to be 50. The borrow amount from the pool is going to be 50. Leverage is 1.5. The collateral is 100. Let's open a long position on my pool. Okay, so this ID is currently not authorized for leverage trading. Let's see if it's authorized. Okay, so what happens is when you create a pool, right then our wallet is authorizing if the correct wallet ID, wallet address is creating a pool or not. And when you open a trade, we analyze one more time if the one which is using or creating a trade is an authorized wallet or not, or is it an agent, or is it something else. So right now we just authorize if the one creating the wallet is an authorized wallet or not. Next we have a spending cap request. So well we have a of 100 tokens. So the 100 tokens is going to be going from my wallet address to the contacts. That is the pool manager contact address. Transaction is successful. Now what's going to happen is we are going to be opening the leverage trade. Minus 100 to the pool. And our position is open successfully. Let's look at the position on Sequoia. Hmm. We have a pretty cool URL. Uh, yeah, the transaction is success. As you can see, token transfer for 100 token from this ID to my contract. And here are all the contract interactions that's happened just now. So let's understand what just happened. We have created a way where Uniswap pools can give leverage in by checking a few conditions to traders. Currently, Uniswap pools can only allow their LP providers the rewards which they get from swap fees. Now, let's say if an asset in a pool is abundant and one is scarce, the abundant asset can be given as leverage to traders, and the rewards which we get from that trade can be again included in the pool, which benefits the liquidity providers who are providing liquidity in that pool. It solves two major problems. First is the problem of impermanent loss on Uniswap pools. And the second, and one of the most major problems, is that assets on Ethereum are currently sitting assets. They are not much liquidity. There's not much liquidity right now. Most of the assets are sitting in pools, in yields, and they are just slowly accumulating things. Rather than that, how about we create a liquid economy where sitting assets can be used as leverage, which traders can benefit from, and as well as benefit the liquidity providers, which choose those assets to stake on any platform. So this is just a basic PPT of what we have created. This is our leverage hook contract. Our leverage hook extends before swap, after swap, and before remove liquidity and after add liquidity. It extends all four of Uniswap hooks. Let me also show you my hook addresses. So here- here's my hook address, pool manager. Here's my leverage hook salt, and here's my leverage hook address. Now, how does eigenlayer fits into the picture? Let's understand that. Um, Eigenlayer operators just scattered across networks deliver us constant real-time prices for our pools to keep going. Here we have a script which registers two operators, which are currently my own custom operators. One operator's work is to scan prices, and another operator's work is to scan the people that's coming in and the transactions happening on a pool. So I've deployed both of those operators on a server right now and working on it. So yep, we have deployed two eigenlayer operators, and I have a screenshot of that image with my GitHub repo. Thank you, and this was Shinrai.